Hello, everyone. Today we're gonna go over problem 9.12, and this one here, this problem is kind of different in the sense of we're going to incorporate the gasket plates in an angle shape with dead load and life load and see their adequacy. So this problem connects pretty much with 9.4 that we solved previously. So the problem statement reads, a tensile member in problem 9.4, which what you see here in the bottom, let me grab my pen, which what you see here, it's an angle. It's subject to a dead load of 30 kips and life load of 60 kips. Is the member adequate? So first what I need to do is to find the yielding in the gross area. This is equation 9.1. So 9.1 equation is PU equal 0.9 Fy Ag. 0.9 times 50, which is Fy, from table 9.1, times the gross area that it's given in the problem 9.4, which is 5.8. So our yielding in the gross area is 261. Then we go for the rupture net area and calculate the PU from there and see which one controls. So the equation 9.2 is PU equal 0.75 FU times AE. So 0.5 times 6.5, 65, excuse me, from FU from table 0.9 times the AE, the effective area, which is a 3.77. Again, this should be from previous lectures of how we find them. Typically, in this case, is the effective area is AN times U. If you go back to the previous lectures, you understand how AN and U is the shear leg U is found, and then the effective area is 3.7. Then if you plug in chug, your value for PU for the rupture net area is 183.79 kips. Now, which one controls? Again, the larger the smaller control, because it fails first. So then we go to the design and we say, okay, what's the load combination we should use here? Well, since we have, dead load and life load only, then it's going to be 1.2 dead load plus 1.6 life load. So then 1.2 times 30 plus 1.6 times 60, which is 132. So then having the controlled value of PU, which is 138.7, is larger than the external effects, dead load and life load, the design load, which is 132. And because of that, our internal forces are larger than the external, which means the member is adequate. Okay, so then whatever load that is acting on the member having this value, up to this value, we still adequate as long as it's below the 138.79. Okay, so with that, I'll stop here.